How's it going? Welcome. This full screen so we can start talking about, not that, there we go. At the beginning, oh, there we go, sequences. That's what we're talking about. And so as we just jumped off of looking for rational numbers and irrational numbers and sort of looking at what some of the patterns were that would help us to be able to determine whether something was rational or irrational, we're going to continually looking at sort of the patterns, and this time the patterns are in succession, and so we call them sequences. So, here's an easy pattern that you've known about since, I don't know, kindergarten, first grade, A, B, A, B, A, B, A, B, that sort of thing, and it goes on and on and on and on and forever. And some of the other patterns you might have seen are circle, rectangle, circle, rectangle, circle, rectangle. So it kind of goes back to those, a number corner maybe that you did, that you'd see a pattern as you went through, and there would be a sequence of patterns, or you might have a third one. And then there's this pattern here, and how many people think they know what the pattern is that we're talking about? If the answer was there are a couple of them, then maybe there are. So one pattern you might notice is it's red card, or sorry, black card, red card, black card, red card. You might notice that these are in sequential order, king, queen, jack, 10. You might also notice that the cards get progressively smaller. So the next card that we would draw might be, somewhat of a black 9, and it might be a little smaller than this. So that's the sort of thing we're looking at. So we're going to look at numbers, sequences of numbers. And here's 4 of them real quick that we could look at. And there's sort of a pattern that emerges as we go through this that'll help us predict what the next number in our sequence is. And hopefully the obvious one, the next number here is 7. Because what's happening as we go through, my handwriting's awful. Let's see if I can make it 7. There you go. What's happening as we make a jump from this to the next, we're adding 1 every time. Plus 1, plus 1. Right? And that's what we kind of look at. Anyone want to guess what this next one here is? I heard you. It's 12. Okay, so we're just every time adding 2, plus 2, plus 2, plus 2, so forth and so on. And this one, a common difference is plus 3. Every time we try to get to the next number, we add 3. Next number, add 3. So that's going to make that 20. And what's going on here? Every time to get to the next number, looks like we're subtracting 4. Subtracting 4. So my next number would be probably 4, and then we'd have 0, and then negative 4, so forth, like so. Okay? So those are some sequences. It's just a list of numbers in a row, and we're trying to figure out maybe the next number, maybe the 20th number, it depends on what the question's actually asking. Those particular numbers are called arithmetic sequences. So it looks like it spells arithmetic, but we pronounce it arithmetic. Arithmetic. So, if you want to call it an arithmetic series, I won't. An arithmetic sequence, I won't be upset, but it's an arithmetic sequence. And so the terms have a common difference, meaning that we either add a particular number to get to the next number, or we subtract a particular number to get to the next number. Okay, so we have some number and we add to it. So we add or subtract to get the next term. So that's what makes it an arithmetic sequence. Trying to multitask and it's not happening. All right, so then there's this one. This is a different kind, and so if you notice this time we don't have a consistent adder. Now here we're going plus 1, then plus 2, then plus 4, then plus 8 or something like that. But what you might notice is that these are doubling. So to get to the next number, we're multiplying each time by 2. Okay, if you're not sure how to figure that out, we can work backwards. But the pattern is we're multiplying by 2 every time, so the next term is going to be 32. Pattern here, well, if we're not sure, we could do, well, what's 9 divided by 3? That's 3. What's 27 divided by 3? That's 3. So my pattern must be, to get to the next number, I'm going to multiply each time by 3. So to get the next term, I'm going to multiply 81 by 3, and that turns out to be 243. What's happening here? Yeah, they're getting smaller, so you might think we're dividing, which it sort of are, but what we tend to do, again, if we're not sure, is we take the second term divided by the first term and see what that turns into. and we take the next term and divide it by the term before it. And when we do that, 50 divided by 100 is 0.5, and 25 divided by 100 is 0.5. So to get my next number, every time, we're multiplying by 0.5. 0.5. It says 0.5, believe me. And to get to the next one, we're going to multiply again by 0.5, and so 25 times 0.5 is 12.5, and then I'd have, I don't know, 6.25, and then 3.125, and so forth and so on. Just keep multiplying by half, and we get ourselves a sequence. This type of sequence is called a geometric sequence. Okay, and this one, the terms are connected by a common multiplier. And you might hear the word instead ratio. They have a common ratio between the terms. Okay, so we multiply to get the next term. Okay, multiply to get the next term. And again, it's either going to be if it's greater than 1, we end up with an increasing sequence. If it's less than 1, between 0 and 1, a decimal, then we're going to get a decreasing sequence as we go through. All right. So there's a little thing that we like to call a next now equation, and it basically tells us how to get our next number if we know the number that we have now. And so if I look at this sort of arithmetic sequence, every time we're adding 3. So if I were to write a next now equation for this arithmetic sequence, I would write next, meaning my next number, is equal to now, meaning the number that I have now, plus 3. And in order for this to work, I need to know where's my sequence start. And in this case, my sequence starts at 5. So next equals now plus 3, start at 5. That tells us that we've got ourselves a arithmetic sequence because we're adding to get to the next term. On this one, and we've seen this one before, this is the one where we multiplied by 3. So to write a next now equation, basically, my next term is equal to the term I have now, which we call now, multiplied by 3. And where does my sequence start? It starts at 3. So we could recreate that from the information there, recreate that sequence. So there are other types of sequences that we're looking at, and at this point we're only really worried about the arithmetic and geometric types, but we'll explore a couple others just so we have an idea of what we might look for or might have to look forward to in the future. So this one, if I go with the arithmetic model, we add 3, and then we add, 9, right? And then we add 15, all right? And then we add 21. And so we're not having a constant adder. If you did the multiplication model, we're not going to get a constant ratio. What we might notice is that if we look at the difference between here is plus 3 to plus 9, this difference is plus 6, this difference is plus 6, this difference is plus 6. And so that would indicate, well, it indicates that it's not either arithmetic or geometric, but it would indicate to us also that we probably have a quadratic sort of model. And we're not going to worry that much about calling it that. Really, for purposes of our argument, we're going to say that's neither. It's neither arithmetic or geometric, but that would turn into a quadratic model. This particular one is 1, 1, 2, 3, 5, 8. Anyone want to guess what the next number is? Anyone? Well, if we look at 1 and 1, we get 2. If we look at 1 and 2, we get 3. If we look at 2 and 3, we get 5. 3 and 5 gives us 8, so what's the next number? Okay, 13, because we take 5 plus 8 to get to 13. So this, and I'm going to possibly spell it incorrectly, you can check my spelling on someplace, is the Fibonacci sequence. Okay, but again, for the sake of what we're looking at for right now, we'll call that neither. And so our task is to look at, is it arithmetic, is it geometric, or is it neither? And so what we're looking for is arithmetically, do we have a constant plus or minus? For geometric, do we have a constant multiplier? Or do we have nothing going on? So the easiest one is probably just to look. Do we have an arithmetic? We're going from 8 to 4 to 0 to negative 4. Looks like we're subtracting 4. So I'd call that one arithmetic. This one, plus 7, plus 7, plus 7. Ooh, 2 arithmetic ones in a row. And you can work the next 3 and show me those later on and see what you come up with. So the choice is either going to be an arithmetic, a geometric, or none of the above. Neither. All right. And the other thing you can do after you've watched the video is make your own. So make an arithmetic sequence that starts with the number 12. Go out 3 or 4 terms so we know that you see the pattern, so we can figure out what's going on. And also make a geometric sequence that starts at 12. So give me 1, 2, 3. Give me 4 more terms on that one. So 1, 2, 3, 4 extra terms starting with 12. Arithmetic. Do what you need to do to make an arithmetic sequence. Do what you need to do to make a geometric sequence. I think that brings us to the end. It does. So I'll stop and leave that on the screen so you can make those 4 lines and remember to do them. I do appreciate you watching. I hope if you have questions you'll ask. And I do hope you actually learned something. So thanks. Talk to you soon.